So for the example of case 2, say let's evaluate d of x all over the x minus 1 that is raised to 2. Okay, so we have a linear factors, but is repeated with n is equal to 2. So resolving this into partial fractions, we have x over x minus 1 squared is equal to a, our first constant, all over x minus 1, then plus b all over x minus 1 raised to 2, and we will end up here because our n here is 2. Okay, so by multiplying its LCD, we have x is equal to a times x minus 1 then plus b, right? Okay, let me show you. By x minus 1 squared. Okay, so this one multiplied by this one, we have x, and a all over x minus 1 multiplied by x minus 1 squared, so we have x minus 1, and we have left with x minus 1. Then for b, we have to cancel out x minus 1 raised to 2. Okay, so all in all, this is now our new equation. And to our next step is to resolve the value of a and b. Okay, so we may use, if we let x is equal to 1, then we have 1 is equal to, if we let x is equal to 1, so our x here is equal to 1, a times 1 minus 1 plus b. So we have cancel this out, 1 is equal to b, or b is just equal to 1. And then how can we solve the value of a? So since b is not multiplied by any x, so we may let any value of x, but must be in terms of smaller values. Okay, or we may assign value to our x, but preferably we need to assign smaller values. So we say let x is equal to 0. So what will happen to our equation? We have, if x is equal to 0, then we have 0 is equal to a times 0 minus 1 plus b, right? But 0 is equal to 0 minus 1 is equal to minus 1 multiplied by a, we have negative a plus b. So getting the value of a, we have a is equal to b, right? And we know that from our previous equation, we get the value of b, which is equal to 1. So if b is equal to 1, then a is equal to, we will get the value of b here, so b is equal to 1, so a is equal to 1. So all in all, our b is equal to 1 as well as a. Okay, then we may now proceed to our equation. This is equal to the integral of a all over x minus 1 plus b all over x minus 1 squared d of x. Okay, then from here we say that our a is equal to 1 and b is equal to 1. Therefore, this is only equal to a or 1, since a is equal to 1, all over x minus 1 d of x, then plus integral of b, or in our b, is equal to 1 all over x minus 1 squared dx, right? So from here, we can now perform integration. So this one is that we have ln of x minus 1, but here we have um, integral of u negative 2 du, or u negative 1 plus c all over negative 1 x minus 1 minus 1 over our u is x minus 1, then plus c. Okay, so what we did here is that we let u is equal to x minus 1, then our du is dx, right? Then we transform this into integral of where dx is du all over x minus 1 is u, so we have u squared. That's why if we move this u squared in our denominator, we need to once again make this positive to negative. Okay, if we will move this in our numerator, so we have integral of u raised to negative 2, and from here we apply the power formula to integrate this kind of integrand. So we have negative 2 plus 1 is just negative 1, but it is all over to the new power, which is negative 1. That's why we have come up with negative 1. This is negative 1 u, wherein our u is x minus 1 negative 1, and we can rewrite this like this: negative 1 over x minus 1. This is positive 1 now. If we will move back our x minus 1 at the denominator to make it positive, so we have x minus 1 raised to positive 1, or just x minus 1, then our plus c. All in all, this is now our final answer from evaluating x dx all over x minus 1 squared. This is now our answer.